Hi, my name is Peter Adams. I am a professor at Carnegie Mellon University. I trained as a chemical engineer, but I've always wanted to do environmental engineering, and I felt that chemical engineering was the best background to do environmental engineering. I've always been very interested in engineering in the broadest sense, and how engineering interacts with society, and how policy plus good engineering can help us manage air pollution and other sustainability challenges. So my teaching involves really three pieces: air pollution, climate change, and how they interact with energy systems, so that we can solve the climate change problem and the air pollution problem together. I strongly believe that the demand for sustainability knowledge is not limited or specific to one field of industry. Sustainability is a huge challenge with lots of different factors: economic, environmental, and social. And all the industries have an important role to play, so that the demand will be important no matter what field of industry a student chooses to go into. One of the biggest myths about engineers is that we are narrow, focused people who only do science and math. The best kind of engineer is a much broader person who understands the technical details of science, engineering, technology, math, and so on, but puts them in a much broader context of understanding what society needs, what business needs, and how governments create policy to deliver on all these objectives. So the core of my research is around air pollution, air quality modeling. And these are the tools that policymakers use to link how the emissions that we have now and changes that we make in the emissions will link to cleaner air and therefore healthier people and saving lives. Specifically, what I try to do there is work in two different areas. One is we have very detailed science and chemistry models that we use as the benchmark. But on the other hand, we also use decision support tools. So we try to translate the very complicated science models into simpler forms that policymakers, decision makers, business managers can use to quickly assess the benefits of decisions that they're making and quickly map those into health benefits in a way that's very scientifically calibrated. My career journey has been an interesting one because from a young age, when I was in high school, I was always very passionate about the environment and making environmental improvements. I was never entirely clear whether I wanted to do more science and engineering on the one hand, or whether I wanted to do more law and policy on the other hand, because both were very appealing to me. It's really lucky that in the end I was able to land in a job that really let me blend those two in an interdisciplinary way. Along the way, I was fortunate to have a lot of mentors. I had a family friend who was an environmental lawyer. Nobody in my family were engineers, but we had family friends who were engineers that woke me up to the exciting possibilities of being an engineer. In undergraduate, I was fortunate to have really two professors who mentored me a lot. One who introduced me to research in the lab, and another who introduced me to helping him teach a course. I learned a lot from them, and they were very important in my decision to go do graduate school and get a PhD from Caltech. I was fortunate to have an outstanding PhD advisor when I was at Caltech. I learned so many things from him. Maybe the thing that I remember the most, because it was a painful process in a good way, is how to write technical reports and research papers well. This is perhaps another myth about engineers, is that they are not good writers and they don't need to write. Engineers need to be good communicators, and I learned that from my research advisor. Last but not least, not exactly mentors, but at Carnegie Mellon University, I've been really lucky to have outstanding collaborators in a lot of different ways. Colleagues who I've worked with for 20 years on air pollution, people who I collaborate with on energy systems, and so on. First, I think NAMTech has a really beautiful campus. It's a beautiful modern building with lots of space. All of my colleagues at Carnegie Mellon University would be extremely jealous of the amount of space and quality of space that's here on NAMTech's campus. The other part that I found really interesting about my time at NAMTech is the broad vision that NAMTech has for how to train engineers. So, of course, it always starts with science, technology, engineering, math. Those are the core skills that any engineer has to have. But I really feel like the difference between an average engineer and a truly successful engineering leader are the engineers that are able to understand and deploy that technical knowledge with broader skills, thinking about business needs, thinking about management, thinking about policy making, thinking about sustainability. And it's the breadth of the education that NAMTech is trying to provide that I think will really make an important difference. Something that I think will make NAMTech students really stand out is the breadth of the education that they're getting. It, of course, always starts with excellence in the core technical skills, science, technology, engineering, math. But what will make a student really stand out is the ability to deploy that technical content, understanding the really broad societal environment that engineers operate in. So, what is the business environment and what are the constraints? What are the technology constraints? What does society need? What does the public want? And how does policy shape everyone in towards working together to meet societal goals around sustainability? What's really exciting about India right now is that the public and the government is really starting to awaken to the importance of addressing the air pollution problem. And so it's a space where the problem is new and really anything can happen. And I'm excited to see what will happen in India over the next 5 and 10 years as the government and businesses work together to try to address this problem that's recognized to be important. My research in India has really had a couple different dimensions about air quality modeling and using air quality modeling to inform smart policy making. And so over the last 2 years, I've been working with an excellent collaborator at IIT Kanpur in developing a set of air quality models for India that will support decision making. So there are many complicated physics and chemistry models that simulate air pollution in the atmosphere. Policymakers and business decision makers need a simpler set of tools to rapidly inform scenarios that they're thinking about pursuing. And so we worked on developing a set of decision support tools for India that are now becoming mature. And I've lately been working closely with the C-STEP think tank in Bangalore to train them in those tools so that they can start to use them in assessing policies, informing policy making, and also disseminating those tools for wider use. So in my time with the NAMTech students, it was really exciting to engage in discussions with them. They're a really dynamic and interested set of group of students who will really want to engage on almost any topic and think very broadly about engineering and policy and business and sustainability. And so I really like to see the breadth of the vision and all the different things that they're thinking about from a very young age.